Now let us study about trajectory of a 2D motion. Now first of all, let us define what a trajectory means. Trajectory is simply a path that is traveled by a particle from any initial point to final point. Let us say that if a particle is traveling in a plane, because it is a 2D motion, and in 2D motion we have already studied this is the motion in plane. So if there is a particle in XY plane and it's traveling like this from point A to B, then this path that the particle is following from point A to point B, this path is called the trajectory. So trajectory is nothing but the path of motion of a particle. Whatever path, this path can be of any shape, any which way the particle is moving, that particular path, the direction of that path and the shape of that path, that is called the trajectory. Now when a particle is moving in an XY plane like this, its position is changing both in X direction and in Y direction. That means that if we take any point, then at this point it will have some value of X and then it will have some value of Y also on the same point. That means there can be an equation which relates X and Y. So there can be any function y equals to fx. This is called the function of this is called y as a function of x. That means the value of y is depending on the values of x. So y is a function of x. Now at a particular instant, if the position of particle is given by x and y, then both of these positions x and y can be expressed in terms of t. So we can say that x is a function of t. So we can write it as x equals to f1t, and we can also say that y is also a function of t. So y equals to f2t. As we have already studied that in a planar motion, in a two-dimensional motion, time is the common variable between x and y positions. So at any instant of time, x, the position x will be given by this function and position y will be given by this function. Now this has time as common variable. So if these two functions give us position of particles at x and y, and if we relate these two functions, then t can be eliminated because it is common, it can be taken out, it can be eliminated, and as a result we are going to get a function like this in which y depends upon x, or x will be a function of y. Any which way we'll get a relation between x and y. So let us do a solved example. Let us say that if there is a particle which is traveling in a 2D motion with velocity given as v equals to 4t I cap plus 5 j cap. We have to find the path of motion of particle, what kind of path it is, find a path of motion, and its equation of trajectory, that is the equation between y and x. So to solve this, if we notice the equation, then the velocity is already divided into two components, 4t I cap, that means 4t will be x component, and 5 j cap, that means 5 will be y component. So you can write that x component of velocity, we can write it as vx and it will be equal to 4t, and y component of velocity, we can write it as vy and it will be equal to 5. We can also give them units. Let us say 40 meter per second and 5 meter per second. Now as we can see that velocity in y direction does not depend upon time. That means it is constant with all the values of time. The particle is moving with a constant velocity in y direction. We can express the position of particle in y direction as 5t, as in the distance traveled. That what will be the distance traveled in time t in y direction. So that will be given by 5t. If we say that velocity is 5 meter per second and the body is moving for 10 seconds, then what will be the distance covered in 10 seconds? Then we know that the distance will be velocity into time, so it will be 5 into t, so that will be equal to 50 meters. So that way we can write that the distance traveled in y direction can be given by this particular expression yt. In x direction, however, in x direction Vx is given as 4t. Now we have the velocity which is dependent upon time. So we already know how to calculate the position from this. We know that Vx can be written as dx by dt. This will be 4t, or we can write dx as 4t dt, and to get the value of x we will integrate this function. Now since the since the particle is starting from the origin, that means at the times t equals to 0 the position is x equals to 0, and at time t equals to c, let us say that the position is x. If we solve this, we will get x equals to 4t square upon 2, so that will be 2t square. So this function 2t square will give the position x, and 5t will give us the position in y direction. Now we can see that t is the common variable, as we discussed earlier. T is the common variable. Let us see that if we can eliminate this t. Now from this equation here, this is y equals to 5t, so I can write here as t equals to y by 5. And if I put this value of t in this equation, in the equation of x, then I can write it as x equals to 2 into y by 5 whole square. So now we can see that the common variable t has been eliminated, and we are getting a function which is relating x with y, which is relating the position along x direction with the position along y direction. So if we solve it further, we can write it in the form of y equals to fx. We can write it as y equals to solve this, you will get this, y equals to 5 of root x by 2. Now this is the equation of the trajectory, which is in the form of y equals to fx. So equation of trajectory will be this one, y equals to 5 root of x by 2. And what is the path of motion? Now since this is a quadratic equation, it is a quadratic equation. A quadratic equation, as you must have studied in class 10th, in maths you must have studied, there were some few graphs that were given in the starting of the chapter of quadratic equation. So whenever there is a quadratic equation, the path that the graph follows is a parabolic path. It is a parabolic path, or we can simply call it parabola. So they are all curved path like this or like this. In the 10th you must have studied this. So we can see that the trajectory will be defined by this equation, and the path of motion will be parabolic. It will be a parabolic path. So this will be the solution, and this is how we attempt to find the distance traveled, or the displacement traveled, or the position of particle in a two-dimensional motion. We took common variable t, we eliminated t, and found a relation between x and y. Now we are going to apply the same concept in finding the next topic. Let us say that we have to find the distance traveled by a particle in 2D motion. Now we already know that distance is the length of path. So if we have a motion in xy plane, let us say the particle starts from A and it is going like this, and the final point is B. Then if we are calculating the distance, it will be the length of path. If we are calculating the displacement, then the displacement will be given by the shortest path length. So it will be the position vector connecting A and B, where A will be the initial position and B will be the final position. So the position vector connecting A to B directly in a straight line will give us the displacement. But if we need to find out the distance, then we have to integrate the total path length from point A to point B. So for doing that, let us say that a particle is at position P at certain instant of time, and its coordinates are given by x and y. Now the particle is moving, so it will have some velocity vector which will be given by the tangent at point P. Now because of the velocity, let us say that in a small time dt is a very small time, in a small time dt the particle comes to a new position by covering a length dl, by covering a path length of dl, and its new positions. Let us say the path length covered in x direction is dx and the path length covered in y direction is dy. So if the initial position was x, then after covering dx, the final position at this point will be x plus dx, and covering dy in this direction, the final position at y will be equal to y plus dy. So this means that if we need to find out the total path length from A to B, then we have to integrate such kind of equation. We have to integrate this small dl. There will be several dl's like this in from A to B, and if we integrate all of them, we'll find the total distance or total path length from A to B. Now from this small triangle, we can see that this is a right angle triangle and this hypotenuse is the dl. So by applying Pythagoras theorem here, instead of dl we can write root of dx square plus dy square by applying Pythagoras theorem. Now we can take dx square common, then inside it will be equal to dy square upon dx square. If dx square is taken out of the root, then it will be dx and it will be equal to this. Now as you can see that the integration is happening with respect to x. So the limits that will be put here will be of x only, and we can write that the total path length from A to B can be given as this particular equation, where the initial position say xa and final position xb, we are taking xa and xb and not ya yb because we are integrating with respect to x. Now this will be your equation. This will be a very important equation and it can be used directly to find out the distance between any two points A and B. It's not just initial and final point, between even in the distance in the entire path between A and B, we can use this formula to find out the actual path length. Here dy by dx, as we know that if the trajectory is suppose given as y equals to fx, then we can easily find dy by dx by differentiating this. We will find dy by dx and we can directly put it here and apply the limits and we will be able to find the total path length.